Hey everybody, I got my paper computer kit right here. This is my starter kit. This is my cup of tea. So what we're going to talk about today is CardBasic cards. So we'll put the booklet away and we'll put the paper computer itself away. Just put them over here. And these are the two decks of CardBasic, CardBasic 1 and CardBasic 2. So this is just a brief overview to talk about three things. What is CardBasic? How do you use it? And why do you need it to use the paper computer? All right, I did a terrible job of opening the cards. So here's everything that comes with deck 1. Now let's talk a little bit about CardBasic. We're just going to take the very first algorithm in card deck 1. And what you're going to see is that CardBasic is basically plain English. For example, this card here is step 0 for algorithm 1, and it tells us that we're going to set up a test. And this test, we're going to calculate the first 8 numbers in the Fibonacci sequence. And it even tells us what the Fibonacci sequence is. It's this marvelous sequence of numbers that I could gush about all day. 0, 1, 1, 2, 3, 5, 8, 13. Lots of interesting properties in this sequence of numbers. And then it tells you the steps that you need to do to get ready to perform this algorithm. The CPU is in charge of the computer, and so you're in charge. You're the CPU. You configure into 16-byte mode. We'll talk about what that is later. You locate the worksheet, which is the Fibonacci worksheet in your workbook, which is actually, after all of this introductory text, boy, somebody wrote a lot of text there. Right here, here's the Fibonacci worksheet, and you locate your variables, which will be in your paper computer deck, and then you continue to step 1. So that's very plain English. You know, it's not too bad. The idea wasn't to create like a whole new programming language called CardBasic, but rather to create a sort of translation of a computer language like JavaScript or Python into very, very plain English. On the back of every CardBasic card is a visual representation, sort of a snapshot in time. And what you see in this snapshot in time is a representation of what your index cards are doing, what your variable cards are doing, what your CardBasic cards are doing, and then where you are in the algo map, which is in your worksheet. So right here, you can see we're on step 0 according to this CardBasic card. So I'm going to just lay out these CardBasic cards. And the idea is not to get like too computery about this computer language. This is not a Turing complete computer language. This is just trying to describe the instructions that you have to take as a CPU in very basic steps. So there's a lot of action verbs here, like place. You know, this might translate set index 0, right? Set left to 0. And here we're placing the variable left above index 0, which is equivalent to computer code that's something like, left equals 0, right equals 1, right? But we're using verbs like place right above index 1, place num below index -1. And then you record the value of left and right in your worksheet. I wonder why I keep closing this. So here's my worksheet, and I would record the output right here. So the Fibonacci numbers, left, right, num, 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 num. See? So you have a spot to record the progress as you work through the algorithm. And if you just follow these steps, one after another, it's pretty easy. And like I said, if you get concerned, you just turn it over. And here you are with this visual representation that visualizes each of the steps for you. Now, this doesn't replace reading through the steps. And one of the things that's really important is that you learn to read code. And so this is a great start, right? You're not really reading code, you're reading English, but eventually you'll see how each of these lines corresponds to code. One of the most important cards is the continue cards, like continue the main loop, start the main loop, finish. In a lot of computer code, it's not always clear that where the starting point is, right? Or how you continue or how you finish. And so every algorithm has a loop, has a start and a finish. And so this way, it's very clear with the CardBasic cards. Now, later, we'll go over the Fibonacci algorithm in detail, but now you know how the CardBasic cards work. What you don't know is why do you need CardBasic cards? So you could just take your paper computer and you could set it up and you could work from any algorithm representation that you find on Wikipedia or in a computer textbook. You could write down the steps, but what I've done here is I've kind of broken everything down into very, very simple, very clear set of steps, finite set of steps, following the best practices of what makes a good algorithm, and written in plain English. Later, after you've gone through these algorithms and you feel very comfortable, you should totally do that. Throw the cards away and do your own algorithms. You can even, while you're learning, if you get some ideas, just try it out. But this is a great starting point. It's kind of like a set of training wheels that will help learners of all ages figure out how to ride a bicycle, or in this case, a paper computer. So now you know what they are, why you need them, and how to use them. So I really recommend you get the kit that comes with all of this stuff. Oh my goodness, look at all this stuff. And you can go through the 14 algorithms, which are outlined here on the back. And after you've practiced them and done them, you'll know quite a bit, at least conceptually, about how computer science works, how software code works. And from there, you can start doing your own algorithms and maybe even translating your algorithms into actual code as you pick up a language like Python or JavaScript or Swift or Kotlin, any of the popular languages. Thank you.